In this example, we need to solve the following equation, a over the interval 0 to 2 pi, and b for all solutions. And the equation is 5 cosine x plus 1 equals 3 cosine x. Well, what type of equation do we have here? Notice it has a trig function in it, so it's a trigonometric equation. And how many trig functions are there? Just one, cosine x. And what's the highest exponent on the cosine x? It's just 1. So this is a linear trig equation in one trig function, cosine x. Well, how do we solve linear equations? We want to get all our variables on one side, our constants on the other. In this case, our variable is cosine x, and I think it's going to be easier to collect them on the right-hand side. So I'm going to subtract 5 cosine x from both sides of my equation. And when I do that, I get 5 cosine x minus 5 cosine x adds to 0. So the only thing left on the left-hand side equals 1. Equals 3 cosine x minus 5 cosine x. They're like terms. 3 minus 5 is negative 2 cosine x. Now to get cosine x by itself, all you have to do is divide both sides by negative 2. The negative 2's reduce, and I just get left with cosine x equals negative 1/2. However, if you don't yet feel comfortable having a trig function as the variable in your equation, you can let u equal cosine x, and then our equation becomes 5 times cosine x, which is u, plus 1 equals 3 times cosine x, which is u. Then how do we solve this equation? You're going to subtract 5u from both sides. So you get 1 equals negative 2u. Divide both sides by negative 2. We'd get u equals negative 1/2. And then we'd substitute back that u equals cosine x. But after a little practice, you'll become more comfortable with this first method. So we know that the cosine of x is negative 1/2. Negative 1/2 is a value on the unit circle. Here is my unit circle. And remember, the coordinates of points on the unit circle, the x-coordinate is the cosine of theta, and the y-coordinate is the sine of theta. So I'm looking for points whose x-coordinate is negative 1/2. So going around the unit circle, here's my first one that has an x-coordinate of negative 1/2, and the second one is down here. Now, in part A, I have to find values of x over the interval 0 to 2 pi. So I have to be in radians. So the values of x are 2 pi over 3. And my second solution is 4 pi over 3. So that is the answer to part A. They're the only 2 points on the unit circle between 0 and 2 pi. That means within one revolution whose x-coordinate is negative 1/2. In part B, I need all solutions. So I need all angles that are coterminal with 2 pi over 3 and 4 pi over 3. How do you find coterminal angles? You add and subtract one revolution, and since I'm in radians, that's 2 pi. So my solutions are going to be x equals 2 pi over 3 plus 2 pi times n, where n is an element of the integers. It can be any integer. And the other one is x equals 4 pi over 3 plus 2 pi n. So that is the way we write all solutions to this problem.